In this example, I'm going to show you why you need to learn your sum and difference formula identities. Now, you're going to be asked to find the sine, cosine, and tangent of different angles in this section. And each of the angles that you're given will not be on your unit circle, and you can't use a calculator. So our example is sine and cosine and tangent of 15 degrees. And 15 degrees, not on my unit circle, but it is the combination of two angles on my unit circle. 15 degrees is equal to 45 degrees minus 30 degrees. So if I look at my pattern for sine of alpha minus beta, because we're going to use 45 minus 30, the pattern is sine of alpha times cosine beta minus sine beta times cosine of alpha. Plugging in 45 for alpha and 30 for beta, then I get sine of 45 times cosine of 30 minus sine of 30 times cosine of 45. Using my unit circle, 30 degrees is your first angle, and that coordinate is square root of 3 over 2, 1/2. The next angle is your 45 degree angle, and that angle is square root of 2 over 2, square root of 2 over 2. Now, sine is your y value, so the sine of 45 is square root of 2 over 2 times cosine of 30, square root of 3 over 2, minus sine of 30, 1/2, times cosine of 45, square root of 2 over 2. Now, multiplying square root of 2 times square root of 3, square root of 6, 2 times 2, 4, minus 1 times square root of 2, 2 times 2, 4. Adding and subtracting radicals, remember, treat your radicals like variables. Root 6 minus root 2, we keep them separate. It's like a separate x minus y, and then they're both over 4. And that's our final answer for sine of 15. Because we're doing 3 problems on the same angle, we've got a lot of the work already done. We've already figured out what angles subtract to be 15. So now that I'm on cosine 15, I just need to remember the formula. So I have cosine of alpha minus beta. So remember the tricks I taught you. That cosine is stuck up, so it groups only with cosine. So cosine of the first angle times cosine of the second. And then it never tells the truth, so if it's subtracting, we're going to add. And then sine is in the back, so sine alpha times sine beta. Plugging in, again, just like before, 45 degrees for alpha, 30 for beta. We have cosine of 45 times cosine of 30 plus sine of 45 times sine of 30. Same coordinates as before. Remember, the 45 degree angle was square root of 2 over 2, square root of 2 over 2. And the 30 degree angle was square root of 3 over 2, 1/2. So plugging in, cosine of 45 is the x value, square root of 2 over 2. Cosine of 30, square root of 3 over 2. Plus sine of 45, square root of 2 over 2, the y value. Sine of 30, the y value is 1/2. multiplying root 2 times root 3, root 6 over 4 plus root 2 times 1 over 4. Notice how similar the answers are. This is going to happen a lot. So we get root 6 plus root 2 over 4 for cosine of 15. Now, tangent of 15, we actually have two options available to us. So I want to show you the formula first, and then I'll show you a shortcut. So tangent of alpha minus beta, the pattern is tangent of alpha minus tangent of beta. Remember, it's sine on the top, so it follows the pattern. And then on the bottom, it's cosine, so it's a little different. Instead of subtracting, it's going to be 1 plus the product of tangent alpha, tangent beta. So plugging in what I know, tangent of 45, because that was alpha, minus tangent of 30, and then 1 plus tangent of 45 times tangent of 30. Now we have the coordinates written up above in the cosine section where you can see them. Remember, for 45 degrees, tangent is y over x for all the angles. So I have square root of 2 over 2 over square root of 2 over 2. So in other words, same thing over the same thing, 1. For the 30 degree angle, using my y over my x, I have 1/2 over square root of 3 over 2. So the 2's cancel, and I get 1 over root 3. I rationalize, and I get square root of 3 over 3. So plugging in, the tangent of 45 is 1. So 1 minus tangent of 30, square root of 3 over 3. Over 1 plus 1 times tangent of 45 is 1, and tangent of 30, square root of 3 over 3. Now we need to make a common denominator, so anytime you see a 1, remember it's the same thing over the same thing. If our denominator is 3, then it becomes 3 over 3, and then on the bottom the same, 3 over 3. So in the numerator, I have 3 minus root 3 over 3. In the denominator, I have 3 plus 1 times root 3 is root 3 over 3. The 3's cancel, and so my numerator is 3 minus root 3 over 3 plus root 3. As a fraction, this is approximately 0.2679. So I'm going to write 0.268. Now, I want to show you another option because that was really complicated. And when you're having sine and cosine in your problem, remember that tangent is sine of theta over cosine of theta. So I can use this same relationship to find an easier way to find tangent because I already found sine, which was root 6 minus root 2 over 4. And then I already found cosine, which was root 6 plus root 2 over 4. If the 4's cancel, then my final answer is root 6 minus root 2 over root 6 plus root 2. And since it's so complex with the radicals, we don't have to rationalize that fraction. Now, even though these fractions don't look anything like one another, 3 minus root 3 over 3 plus root 3 compared to 6 minus root 2 over 6 plus root 2, amazingly enough, if you put it in your calculator, they are both approximately 0.2679. So they're actually the same value. They just look different.